Hi there. Today we will be talking about hyperbola transformations. A hyperbola is a type of conic section, which is the curve formed by the intersection of a plane and a double cone. It looks like two mirrored curved lines that are symmetrical across two perpendicular lines called axes. There are two types of hyperbolas, a vertical hyperbola and a horizontal hyperbola. The standard equation for a horizontal hyperbola with its center at the origin is x squared over a squared minus y squared over b squared equals 1. A is the distance from the origin to the vertices along the x-axis, which is a horizontal axis. B is the distance from the origin to the vertices along the y-axis, which is the vertical axis. The distance from the center to the vertices along the transverse axis, so the horizontal axis, is A, and the distance from the center to the vertices along the conjugate axis, the vertical axis, is B. The vertices are located at plus or minus A, 0. The standard equation for a vertical hyperbola with its center at the origin is y squared over a squared minus x squared over b squared equals 1. A is the distance from the origin to the vertices along the y-axis, the vertical axis, and B is the distance from the origin to the vertices along the x-axis, the horizontal axis. The distance from the center to the vertices along the transverse axis, which is the vertical axis, is A, and the distance from the center to the vertices along the conjugate axis, the horizontal axis, is B. The vertices are located at the points 0, positive 1, and 0, negative 1. So let's start with a horizontal hyperbola translated. We've briefly learned about this concept before, but we'll review it. The top equation is the standard form of a hyperbola with no transformations, which we just saw. The second equation is the standard equation for a horizontal hyperbola with its center at HK. The HK is where the hyperbola has been translated. It's been translated horizontally by h units and vertically by k units. This graph is an example of what a translated hyperbola looks like. Next up, we have the vertical hyperbola translated. The top equation is a standard form of a vertical hyperbola, not translated. The second equation is the standard equation for a vertical hyperbola with its center translated. So y minus k squared over b squared minus x minus h squared over a squared, which equals 1. This equation is translated horizontally by h units and vertically by k units. The graph shown is a vertical hyperbola translated. Next up, we've got the hyperbola rotation. Rotating a hyperbola involves transforming its equation by rotation to change its orientation in the coordinate plane. Let's say we want to rotate it by an angle theta. The rotation involves substituting x and y in the equation of the hyperbola with expressions involving cosine theta and sine theta, respectively. If x prime, y prime represents a point on the rotated hyperbola, and x, y represents the corresponding point on the original hyperbola, these are the rotation equations. Substituting these expressions into the equation of the original hyperbola gives us the equation of the rotated hyperbola. So after substitution and simplification, this is our new equation. This is the equation of the rotated hyperbola, which has been rotated by an angle theta counterclockwise. The rotated hyperbola still retains the essential properties of a hyperbola. It has two branches, and the distance between the corresponding points on these branches remains constant, known as the hyperbola eccentricity. Hyperbola dilation, also known as stretching or compression, is a transformation that changes the size of a hyperbola while preserving its shape. This transformation is accomplished by multiplying the coordinates of each point on the hyperbola by a constant factor. On the left side of the screen, we can see the original parent equation for a hyperbola. If we multiply the semi-major axis, A, and the semi-minor axis, B, by dilation factors, M and N, We can stretch or compress the hyperbola. But how will we know whether the hyperbola will become stretched or compressed? That is an excellent question. If m is greater than 1 and n is greater than 1, the hyperbola is stretched in both directions, making it wider and taller. If m is a fraction less than 1 and n is a fraction less than 1, the hyperbola is compressed in both directions, making it narrower and shorter. If one dilation factor is greater than 1 and the other dilation factor is less than 1, the hyperbola is stretched in one direction and compressed in the other. In red here, we have the normal hyperbola, so their parent hyperbola. In blue, we can see a hyperbola that has been stretched. Thank you so much.